Hello, and welcome to another episode of Talking to the Machine. And today, I have something interesting for you. We'll be talking about what is computers, what is computing, and also we're gonna be seeing some sort algorithms. So, like if you've ever heard of something called algorithms in computing, today I'm gonna be talking to you about that. But before we dive deep into that, yeah, I want to tell you I'm your host, George Githuma, aka georgegithuma.com. And why do you say georgegithuma.com? Yeah, you can check out my website there, georgegithuma.com. Check me out. And as you can see, I'm a self-taught software developer with proficiency in web technologies, including HTML, CSS, JavaScript, Node.js, Python, and React. Yeah, you can read more about that. And actually, we're going to be talking a bit about this self-taught software developer, and today we're going to be talking about learning how to learn. And I'll be taking you through computing and sort algorithms, and showing you how to learn and how to be a self-taught person as myself. You can also check out my LinkedIn profile. Yeah, I can see the followers are increasing. We are now at 2,722 followers. Thank you so much for the guys who follow me. And also you can subscribe to my YouTube channel, Talking to the Machine. We are currently at 20 subscribers. Guys, if you have not yet subscribed, please subscribe. And I can see 14 people viewing my recording yesterday. Thank you so much for the guys who have viewed. So today, as I talk to you, I said we're gonna be talking about learning how to learn. And basically, like the idea is to find a way to navigate your learning material, like navigate a topic. And for today, the challenge will be let's ask the question: what is a computer? What is a computer? So myself, how I will approach this task: what is a computer? I will go to Google, and first of all, think about it. Computer, where does the word computer comes from? It comes from the word compute. So let's look for the meaning of compute, the simplest meaning of compute. And according to the dictionary, compute, reckon or calculate a figure or amount. So I'm gonna be focusing on the calculation part. So to compute is to calculate. So if we say to compute is to calculate, then a computer is something that can calculate. So let's go and see computer here. And as we can see, it's a noun: computer, plural, computers, an electronic device for storing and processing data, typically in binary form, according to instructions given to it in a variable program. A person who makes calculation, especially with a calculating machine. So a computer is more like the person, but like what we know as computers is the machines that we use. And so we can see it's an electronic device for storing and processing data, typically in binary form, according to instruction given to it in a variable program. And so to demonstrate this idea of computing, I'm gonna use something called a sort algorithm. And so let's go and find out what is a sort algorithms. There are actually a couple of them. There are a couple of them, and let's go to gigs for gigs and see. A sorting algorithm is used to rearrange. Keep that for a minute. Okay. No. Okay. We will leave the advertisement there, no problem. So a sorting algorithm is used to rearrange given array or list of elements according to a comparison operator in the element. The comparison operator is used to decide the new order of elements in their respective data structure. For example, the below list of characters is sorted in increasing order of their ASCII value. You can read more about the ASCII value. That is, characters with letters ASCII value will be placed first, then characters with a higher ASCII value placed later. So this is an example. Of so this is gigs for gigs has been sorted out in this arrangement. And I have an interesting so if you go on the side here, you can see there's a couple of them. There's a selection sort algorithm, there's a bubble sort algorithm, there's insertion algorithm, merge sort, and quick sort, and heap sort, and then many. Okay, but today I want us to play around with I want us to play around with the insertion sort, selection sort, bubble sort, quick sort, merge sort, and shell sort. So here we can see we have an array. An array is basically like a list of items, and as you can see, we can randomize it make it random. Okay, and so we want to look at insertion sort. Okay, so let's go back to our definition and look at what insertion sort is. So insertion sort is a simple sorting algorithm that works similar to the way you sort playing cards in your hands. The array is virtually split into sorted and unsorted parts. The values from the unsorted parts are picked and placed at the correct position in the sorted part. So basically, it's a simple sorting algorithm that works similar to a way you sort your playing cards in your hands. So like from maybe the highest to the lowest, the array is virtually split into assorted and unsorted parts. Values from the unsorted parts are picked and placed at the correct position in the sorted part. Okay, maybe these words can be a bit, so for me, these words are a bit like jumbled up. I'm not saying that. So I'll come here and use a visualizer. And a visualizer, if I go to the insertion sort, based on what it's telling me, you can see it is comparing. It's comparing from the first card to the last card. So it keeps on, you see, like it takes that, compares, and places it in the correct position. So it does that, take it to the correct position, take it to the correct position, take it to the correct position, take it to the correct position. And if we go back here and say values from the unsorted part are picked and placed at the correct position in the sorted part. Okay, it's being taken to the correct position. So unsorted, this side is unsorted, if this side is unsorted, and this side is sorted. Have you understood that? So basically, let's randomize that again and go and do an insertion sort, and you can see the values is taken from the side which is unsorted and is placed on this right position on the sorted side. Okay, so look at that. From it is placed in the correct position, 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 correct position, correct position, correct position, correct position. And yep, we have the sorted from the lowest to the highest. Okay, so that is insertion sort. Then we have another form called the selection sort. And so let me randomize this, and then let's go back to the selection sort algorithm. And what does the selection sort algorithm? Sorts an array by repeatedly finding the minimum element, considering ascending order from unsorted part and putting it at the beginning. The algorithm maintains two subarrays in a given array. The subarray which is already sorted and the remaining subarray which is unsorted. In every iteration of selection sort, the minimum element, considering the minimum element considering ascending order from the unsorted subarray is picked and moved to the sorted subarray. Okay, that can be a bit of a jumble up. So let's go to our visualizer and see what is happening there, and then we can be able to kind of interpret the wording. So can you see what is happening here? So there is a sorted side array and an unsorted subarray. So come back to that. We say the selection is repeatedly finding the minimum element, considering the ascending from an unsorted part and putting it at the beginning. The algorithm maintains two subarrays in a given array. The subarray which is already sorted, the remaining subarray which is unsorted. So in every iteration, the selection sort, the minimum element, considering ascending order, from the unsorted subarray is picked and moved to the sorted subarray. So is that what is happening here? Okay, yes. So it gets the minimum from the unsorted and puts it in the sorted, puts it at the beginning. Okay, so this is the minimum here. You see the minimum, always the minimum, always the minimum, always the minimum, picking out the minimum and placing it in the sorted side, and like that, the minimum, placing it on the sorted side up till it is sorted from the first to the last. Okay, so let's go back there. So the selection sort algorithm sorts an array by repeatedly finding the minimum element, considering the ascending order, from unsorted part and putting it at the beginning. Okay, the algorithm maintains two subarray in the given array, the subarray which is already sorted and the remaining subarray which is unsorted. So in every iteration of the selection sort, the minimum element, considering the ascending order, from unsorted subarray is picked and moved to the sorted subarray, the minimum. So let's look at it again, randomize it, put it up again, and now you can see it's taking the minimum and putting it at the beginning. Okay, minimum and putting it at the beginning. So sorts array by repeatedly finding the minimum element from unsorted part and putting it at the beginning. So let's go back here. It goes, all this is unsorted. This is unsorted. If we look at my, is it a, let's see, yeah, this side, no, how, which way? If we look at the diagram, we can see the minimum. We can see the minimum keeps on like being placed at the correct position. The minimum, yeah, if you look at that, the minimum is placed, minimum element from unsorted part, putting it at the beginning. That is the whole idea. I think we get it up to there. Then we go to another form of sort called the bubble sort. So we're gonna randomize this and we're going to look at bubble sort. Okay, and bubble sort, here it's bubble sort algorithm. Yeah, there we go. And I'm using Geeks for Geeks. Shout out to Geeks for Geeks for this information. I'm using Geeks for Geeks to check out all these definitions. So bubble sort is the simplest sorting algorithm which works by repeatedly swapping the adjacent element if they are in the wrong order. This algorithm is not suitable for large data set as it's very average and worst case time complexity is quite high. So we'll look at time complexity on a later video, but like right now, let's just look at how the sorting happens, you know. So it does this works by repeatedly swapping the adjacent element if they are in the wrong position. So let's go to our visualizer and bubble sort this. Okay, So it goes adjacently from the beginning all the way to the end. Are you seeing that? It goes from the beginning to the end, swapping, 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 and it does that, this swap, until it arrives at it finishes the whole array, such that the array is arranged from the lowest to the highest. Okay, so we can track this number 3. It keeps on moving towards the beginning. So number 3, let's look at number 1 here. Number 1 is the lowest. It keeps on moving towards the beginning, and it will move and like this until the swap cannot swap anymore. Okay, so bubble sort is simplest sorting that works by repeatedly swapping the adjacent element if they're in the wrong order. Okay, in the wrong order, and look at that swap. It will swap it until, yeah, I think we are now understanding. I think we are now understanding. So let's look at the quick sort, and yeah, we'll not spend a lot of time on the quick sort. And what does it say? Like merge sort. So maybe we go to merge sort first before we do that. So let's look at merge sort. And do we have merge sort here? Yes, we have merge sort. So what does merge sort do? So the merge sort algorithm is a sorting algorithm that is considered an example of the divide and conquer strategy. So in this algorithm, the array is initially divided into 2 equal halves, and then they are combined in a sorted manner. We can think of it as a recursive algorithm that continuously splits the array in half until it cannot be further divided. This means that if the array becomes empty or has only one element left, the dividing will stop. Okay, so let's look at that. Randomize this, and then let's do a merge sort. So you can see it keeps on splitting. It splits the array into 2. Look at that. Okay, it splits it into 2 until, let's randomize this again, and let's read again. So it's a sorting algorithm that is considered an example of a divide and conquer strategy. So in this algorithm, the array initially divides into 2 equal halves, and then they are combined in a sorted manner. So it divides and combines. We can think of it as a recursive algorithm that continuously splits the array in half until it cannot be further divided. So let's go back here and let's do a merge sort again. Look at that. It keeps on dividing it into 2, then combines it. Okay, divides into 2, combines it until you have that. And it's very quick, you can see. It's very quick. And so then we're gonna go into quick sort. So because we have heard about it, so let's look at quick sort. So like merge sort, quick sort is divide and conquer algorithm. It picks an element as a pivot and partitions the given array around the picked point. Then there are many different versions of quick sort that picks pivot in different ways. So let's look at what that is. So randomize that, and then let's do a quick sort. So you see, it picks a point, and then picks a point. It picks an element at a pivot and partitions the algorithm array around that pivot. Okay, so look at that. Keeps on picking a point. The red line indicates the picked point, and yeah, picks up a point and sorts that point first. Okay, so divide and conquer algorithm, it picks an element as a pivot and partitions the given array around the picked point. There are many different versions of quicksort that pick pivot in different ways. Let's not go further into that, but you can read more into that. But like, let's look at that picking of the point again. Okay, so it organizes it according to the point it has picked. Okay, yep, look at that, look at that, look at that, look at that. And it actually also divides it into smaller numbers. It divides it into smaller numbers until it is all arranged from the lowest to the highest. Okay, and then let's look at this. We have we have done insertion, selection, bubble sort, quick sort, merge sort, and the last one is a shell sort. And yeah, let's go to shell. Do we have shell sort here? We don't have shell sort on gigs, so let's do shell sort. Yep, shell sort. So shell sort is a generalized version of the insertion sort algorithm. It first sorts the elements that are far apart from each other and successfully reduces the interval between the elements to be sorted. The interval between the elements is reduced based on the sequence used. So let's go back to our figure here, and yeah, I'll put up I'll put up the link to this visualizer and also the link to quicksort to gig for gigs, and yeah, the one for shell sort. So let's look at how shell sorts happens. So this one is more like the insertion sort. Okay, it's more like the insertion sort, whereby it first sorts elements that are far apart from each other and successfully reduces the interval between the elements to be sorted. Okay, can we see that here? Reduces the intervals, reduces the intervals, reduces the intervals, reduces the intervals. Okay, let's go back and say it first sorts elements that are far apart from each other and successfully reduces the intervals between the elements to be sorted. So let's look at that again and randomize that, and then shell sort. So look at that, creates intervals, creates those intervals, and then reduces them, reduces them, reduces them. It reduces them until it finally sorts all of it. Okay, so you might wonder, you might be out there wondering, like, where is this thing used? Why we so a simple thing, like for example, when you go to your files on your computer. So let's look at so let's look at, for example, files. So let's look at my recent files. I can see there are recent files here, and there are applications. I have my applications here, I have my desktops here, and I have my documents, and you know, so like for example, if I just go to documents and I want to arrange by name, okay, you can see it's arranged by name. If I say arranged by kind, it arranged by sizes. If I say by application, by date last opened, it can do this thanks to this sort algorithm. This is basically a sort algorithm being used here. Okay, so I'll go back to name, or I'll just go back to none, and none will be the default name. So that is a simple. Let's go to my applications and just arrange them by name. For example, you can see from there A to Z. That is a sort algorithm in action, guys. That is a sort algorithm in action. And let's arrange this by name. Let's arrange this by kind, for example. And yeah, you can see all that. That's a sort algorithm in action there. I'm not sure which one is being used here, but I think it's the most efficient one. And maybe let's talk about that tomorrow, the time complexity. Like, why is it important to look at that in the time complexity, in why sort of why there are different sort of algorithms, and why one is better than the other. We shall look at that tomorrow. Until then, it's been a pleasure, and yeah, let's go. Make sure, as usual, give me follow, subscribe to my channel. You can send this information to anyone who you think will benefit from it, and I'll be very, very glad. Today we didn't have I didn't have anyone comment on my I didn't have anyone comment on my posts. I have three impressions, but I will just take one person here. I'll just check out one person and give him a shout out. Karuri Charles, this guy, one of the guys who follows me. Karuri Charles, he follows me a lot, and he's been commenting on my previous posts, and so today I'll just highlight him. He's an undergraduate student, aspiring project program leader, aviation enthusiast. He's in Karatina University. Let's check Karatina University 2020 to 2024. So I'm presuming 2020, 2021, 2022. He's probably a third year student. Yeah, at doing Bachelor of Project Planning and Management. And he completed his high school, St. Regina High School diploma in 2019. So you can check him out. About him, is currently a second year. Yeah, you need to update this. Are you currently? So personal profile, currently a second year project management student at Karatina University, aspire to lead and deliver successful project programs in the near future. I think you're in third year, if I'm not wrong. But you can comment, tell me which. So follow this guy and check out what he's doing. And that's all from me. Until tomorrow, stay woke, stay fresh, be a good guy, and spread the love. Out. Yeah. Ding. Stop.